Is the screen visible to everyone?
Yes, yes.
So today we on mechanics of fiber reinforced polymer composite structure. Today is the live interactive session number 6 and myself Vanina Mandal. Today I am going to discuss some sample problems for which will be helpful for solving assignment number 7. So let's start. So the first question. In an orthotropic lamina, the direction dependent properties could be controlled by and options are given. So as we can see, first option is selecting the fibers with appropriate strength. You can see in the right side this table which shows the modulus and the shear modulus values of modulus of longitudinal transfer direction values and the shear modulus values of different fibers, carbon fiber, Kevlar, glass fiber. So from comparison, you can see they all have different values, which shows that their strength and their strength is different. Hence, and their strength will be affecting the lamina. Hence, selecting the fibers with appropriate strength is required to have a the fibers can the it can control the lamina. The second is selecting the matrix with appropriate strength. That also you can see in the table, the comparison between different matrices, epoxy matrix and silicon carbide, which is a metal matrix and everything, etc. So we have to select a proper matrix which will also uh, define the strength with and and they will also control the direction dependent properties. And the third is the selecting different fiber orientation, as depending on the global axis and the principal axis, the angle in which the fibers are aligned in the lamina, they affect their properties in that direction. So overall, in an orthotropic lamina, the direction dependent properties could be controlled by selecting a proper fiber and matrix and also the orientation in fiber. As sir taught in the class, this was a statement that sir used, that it depends on the directional properties could be controlled or tailor made by changing types of fiber matrix, and for a given fiber matrix combination, it can be further changed by changing the fiber orientation and also the fiber volume fraction. So next question, it's a simple numerical. It says the lamina with thickness 0.1 mm has a longitudinal tensile strength given 1500 megapascal. The width of the lamina required to withstand tensile load of 150 kilonewton in the longitudinal direction. And here I showed in x direction as the longitudinal direction 1 and took it as the principal axis as 1 in this direction. So when we're talking about the load in one direction, we take the area which is normal to the applied load. So from that we can get this equation that tensile load is equal to tensile strength into the area, which is the normal area in the direction in which the load is given. So values are already given to us. The tensile load is 150 kilonewton. Make it in SI units, like kilonewton, take it at 10 to the power 3. Here, megapascal, take in 10 to the power 6. And by taking care of all the units, we can get the width of the lamina, which is 1 meter. Next is, in a lamina, the transverse stiffness and transverse strengths are. So, what is the transverse? Whenever there is a lamina, there are fibers are aligned on it. So, the direction in which the fibers are aligned is considered to be longitudinal direction. So, any direction which is perpendicular to that longitudinal direction is the transverse direction. Now, we know that fibers in a lamina, in the direction which in the direction in which they are aligned, they give high strength in that direction. But what about the matrix? Matrix distributes the strength. So compared to the longitudinal direction, in transfer direction, it is dominantly decided by the properties of the matrix, because the fibers won't have much effect on the transverse direction, as they are more have higher strength in longitudinal direction, but the matrix is used there to combine the strength of fibers and also to distribute it. Therefore, it is more dominant in the transverse direction. Next is the strength and stiffness of a laminate are decided by only the strength and stiffness of constituent laminae in the laminate decided by both stocking sequence of the laminate and the strength and stiffness of constituent laminae, independent of strength and stiffness of constituent laminae, independent of stocking sequence. So it is as if we are talking about the strength and stiffness of the laminate, it definitely depends on the strength and stiffness of the constituents of the lamina in the laminate, but also in the stacking sequence, because more the different angles the fibers are aligned, it is the whole laminate will have more proper distribution in those angles. Because for example, if you took a stack of all 90-degree angle fiber orientation in the lamina, and you will find that the strength in longitudinal direction is more compared to the transverse. Whereas if we take different angles like 0 degree, 45 degree, then because of the fiber orientation, the strength will be distributed in other angles and other direction. So it will affect the whole strength and stiffness of the laminate. Hence, the stocking sequence is also very important. Hence, the answer will be that it is the strength and stiffness of laminate is decided by both stocking sequence of the laminate and the strength and stiffness of the constituent laminate. Next question is, which of the following is the correct unit of force resultant in classical lamination theory? So, according to classical lamination theory, the resultant force can be given, is shown by this direction in x, y and xy direction. Here you can see it is the summation of all the shear strength in one direction of each lamina. So the resultant force, or this summation of all the stresses in one particular direction is being combined into a force variable, which is known as the resultant force. And the units that are taught, that force resultant has the unit as force per unit weight. So force is Newton and unit weight will be meter. So it is Newton per meter. Next, the same thing, they talked about which of the following the correct unit of moment resultant in classical lamination theory. So, moment resultant is equal to is known as moment per unit width. So, according to that, the unit will be Newton meter divided by meter. So, the final unit will be Newton. Now, the next question is, two laminates with identical dimensions are made from same glass epoxy lamina with same lamina thickness, but with stacking sequence 0, 90, 90, 0 and 90, 0, 0, 90 are subjected to some same axial tensile load. Which of the following is true? So here they talked about mid-surface strain. So mid-surface strain is when there is so when there are different laminas or different angle of stocking, then the mid-surface strain is the strain at the midpoint of the whole lamina. As you can see, here the sequences are in such a way that 0, 90, 90, 0. That means the first one will be 0, the next one will be 90, third one will be again 90, and the last one will be 0. So they are symmetric above and below. And when we took the second option, that is 90, 0, 0, 90, again above the midpoint it is 0 and 90 and below also 0 and 90. So if we combine it, we can see in the after the when there is a mid surface, above it there is a stocking of 0, 90 or 90, 0 and below is also 0, 90 or 90, 0. So they will combining both in if we take 1, 0 and 190, their strains will be similar to that of another one which is 90 and 0. They just opposite rate, but combinedly they will have equal strain. So the answer will be that the mid surface strains in 0, 90, 90, 0 will be equal to those in 90, 0 and 0, 90. Because above and below the midpoint, the properties will be similar, because only 90 and 0 stocking two laminas of this are used. in both the cases. That's why their strains will be equal. The next question is, in a symmetric laminate, they talked about all the elements of the B matrix are 0, only B16, B26 are 0. All the elements of D matrix are 0, only D16 and D26 are 0. First of all, what is a symmetric laminate? Here you can see symmetric laminate is such that when it is separated from the midpoint, the angle of orientation of the fibers are similar above and below in this way. So this is the equation to find the B matrix. We have to consider this graph. So here for mostly symmetric laminates, all the elements of the B matrix are 0. That is, if it is symmetric, then N, which is the resultant force, and with this matrix it is relating to the rotation. So when it is symmetric, then any force will give no rotation to the whole laminate. That's why the whole B matrix is considered to be 0 for a symmetric laminate. So for that we will refer to this matrix, which you can relate from here, that Nx, Ny, this is the resultant force, and when the B matrix is used, it is related to the rotation. So when there is a resultant force in any direction, then there is no rotation when the whole laminate is symmetric. That's why the whole B matrix will be 0. So in the next question, in a cross-ply symmetric laminate 090, which of the following is or are correct? Please don't consider this diagram. Here there won't be 0 degree. So it will be like 0, then 90, then again 90 and 0. So it is the same case as before. It is a symmetric one. So again the whole B matrix will be 0. Then next see other options, A16, A26 equal to 0. Now the A matrix is relating the resultant force to the strain, the mid surface in plane strain. So here you can see A16. A16 is a coefficient which relates the force in x direction and what will be the shear strain in xy direction. So for a symmetric laminate, when there is a force in x direction, there won't be any shear strain in there won't be any shear strain in xy direction for the whole laminate. Therefore, A16 is 0. Similarly, when relating Ny to the shear strain, we can see the coefficient is A2x, which will again be 0 here. That's why they took A16 equal to A26 equal to 0. Then comes the D matrix. So D matrix, here you can see it is relating the moment with the rotation. Moment with the rotation. So for D, when there is a moment in x direction, there won't be any rotation in xy plane. Therefore, D16 will be 0. Similarly, when there is a moment in y direction, there won't be a rotation in xy plane. Therefore, D26 will also be 0. This is only eligible for symmetric laminates. So, cross-ply symmetric laminate. Therefore, all the elements of B are 0. So, all of these is the answer, which is these are the correct statement.
Madam, good evening, madam.
Yes.
Madam, I'm Karthikeyan.
Hmm?
Madam, actually, you solved now previous exam assignment, previous exam assignment problems. But after solution released, the current assignment problem solution we needed, madam. If it's possible to get, madam.
What? I didn't understand. The assignment that you have submitted.
Yes, madam. I have submitted latest assignments this for this exam, but I need this assignment solved uh, answer, madam.
That you can ask sir. You had live session with sir, right?
Okay, okay,
Ask sir about. He will be able to say if they can
okay,
provide the solution for this.
okay, madam. And here some problems are I feel some answer I feel correct, but some mistake is there. So what is correct or wrong is clearly to understand the further examination.
Yeah. Okay. In the discussion, ask this question. Okay, about if if they will be available or not. I think the
Okay.
solutions will be available before the other
Solution
assignment.
is available, madam, but how to solve the method, how to solve this method is not available. So just answer only available.
Okay, then ask in the discussion or when there will be live session with sir, you can put on this question.
Okay, madam. Thank you, madam. Actually, last assignment, sixth assignments, some corrections are told, but previous assignment, fifth assignment, that question number 5 and 7,
I
the
talked
volume fraction.
about it, and he
Okay,
said that he will talk to, like he will look after it. So I asked sir about that question. It was for assignment 5.
okay, okay, madam.
The next question is in a balanced symmetric laminate, for example, plus 45 and minus 45, what will be the what will be the values? So here also the from this you can see it is first it will be plus 45 angle fibers, next will be minus 45, then there will be repeat of minus 45 degree, and then there will be plus 45 degree. But here, because these are in other angles than 0 and 90, so in the D matrix, the moment, when there will be an moment in one direction, there will be rotation in that plane because of this angle. Otherwise, when we consider the force resultant, it will be similar case like before, that when there is force resultant in x direction, there won't be any shear because of that. But for moment, there will be shear because the laminate, the fibers are aligned in a particular, is not 090 but in other angles. Next is a numerical. This is a simple numerical which says a 2.4 mm thick laminate when subjected to in-plane loads experiences mid-surface strains and curvatures as given. So here what we have to take care of, we have to take the midpoint of the whole laminate. So if it's given 2.4 mm, we have to take a midpoint in the middle and take plus and minus 1.2 mm. And then we have this equation which is strain displacement relationship. Here strain is equal to the mid surface in plane strain and the rotation. From this, then we put the values of E naught and kx, ky, kxy in this equation, and for z we have to consider the midpoint and take plus and minus of the half of the thickness that is given of the laminate, and by putting that we can get the final values. Any doubts? Vishwas, do you have any doubts today?
Good evening. Ma'am, in that assignment 7 question, actually it's not a doubt. In the last question, similar to the question which is solved in this class, the last slide. So he has given four options. So I think in the last, six answers there. There are six answers, right? One is for three strains for bottom and three strains for top layer. In the options provided for the top layer, the last term, that is shear strain in that last term, I think option provided there, I think there is some correction. I think
In the sample problem I showed.
no, ma'am, in assignment.
Okay.
Yeah.
Uh,
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 all the mistake is the same in all the four options. That means there are three strains in the bottom, that is we are getting correct, and even the three strains in top we are getting correct. But in the options provided in all the four options, the shear strain in the top layer, I think one decimal, one term before decimal, I think it is missed. We are getting 3.46, there it is 0.46.
mistake. There are some mistakes in the assignment. Maybe it's printing mistake, like typing
Yeah.
mistake or something. Other all values, if you are getting correct, then choose that option.
Okay, okay.
Or
Only that was
also,
the only doubt.
it will be better if you put this in the discussion. What if there is some calculation? There might be some calculation mistake you might have done. So it's better to point it out that you when you solve, this is the answer coming. If it's a mistake, they will let you know that it's from their side of there is some calculation point you might be missing. It's better
Okay,
if you
okay,
put it in discussion.
okay.
Yes, Karthikeyan.
Madam, actually, the first three lecture PPT available in that Google uh, platform, but remainings are not available. Uh, if if possible to upload the again further lectures as a PPTs.
Oh, these sample PPTs are not available in the drive.
Yes, madam. Only three PPTs are available.
Okay, okay, I will check.
Lectures means this one, no? SAR lecture.
SARS lecture.
Yeah,
That sir only put those only.
but three
Uh,
only uploaded.
that actually sir has to talk to NPTEL, and according to that he will have to put. So maybe live
Okay,
session you can ask sir if he will be able to
okay,
put them.
okay, okay, madam. Thank you, madam.
then if we don't have any doubts, then we will end the session here. Thank you.